Let's solve a little more complicated logarithmic equations, and then we'll be done for today. So we're going to start right here with b. Now, right now in log form, this is pretty gross to solve, and I can't really use any properties of logarithms to simplify it, so my best bet is to change it into exponential form and see if I can solve it from there. So we're going to change this into exponential. Base stays the same. The input and the output flips. We get 4 squared equals 3x minus 2. Well, 4 squared is 16. And now I can solve it from there. Way easier to do in exponential form than in logarithmic form. So I get 18 equals 3x. So x equals 6. Sweet. Okay, let's go to a different kind of equation. This equation actually doesn't use logarithms to solve it at all. This is an exponential equation, and to solve it, it's a little strange. So we're going to talk about, I'm going to go back in your notes right here to this, the principle of exponential equality. So the principle of exponential equality says, if I have two things that are equal and the base numbers are the same, so this is like 3 to the x equals 3 squared. So my base numbers are both 3's. Then the exponents must be equal to each other, which makes sense in this example. If I have 3 to the x equals 3 squared, then x has to equal 2. That's the only option for these to be equal to each other. So then I can essentially say, well, the bases are the same, so then I can set these exponents equal to each other. That's the principle of exponential equality, and that's what we're going to use to solve this problem. So the main thing is I have to get bases that are the same. So I am going to change this 27 and this 9 so that they have the same base. So for example, I can change 27 to 3 cubed, and I can change 9 to 3 squared. Now they have the same base. And what I can do is use a rule of exponent we learned about last year. If I have a power raised to another power, then what I do is I multiply those powers. Anytime you have a power raised by another power, you multiply. And now I have base 3 equals base 3. So what I can do is set the exponents equal to each other. So 3 times 2 is 6. Let's distribute that 2, so I get 2x plus 2. And solve for x. So I get 4 equals 2x. So I get x equals 2. And that's my answer. Okay, I'm going to have you try one more, and then I think we're going to be done for today. So this one, I want you to pause the video and try out on your own. And remember, the whole point is that we need to get the bases to be the same number. It doesn't matter what the bases are as long as they are the same number. Pause the video and try this one out, and then come back to see how you did. Welcome back. There are actually two different ways to solve this problem. You could change them to base 9s. So this one is already a base 9, and you could change 81 to 9 squared so that they have the same base of 9, and then solve from there to get x equals negative 15. Or you could also change this one to base 3s. Change 9 to 3 squared and 81 to 3 to the 4th. And then, once again, they have the same bases, and you can solve from there. Still get x equals negative 15. So that's the answer, but those are both different ways that you could solve this problem. Okay, that is it for 10.1. Your homework for today is on the next page, and it is all of these problems. So you can go ahead and get started in working on that, and then don't forget to do your Canvas homework as well.